Hi guys, so in this video we will be solving this problem, minimize Hamming distance after swap operations. Okay, so let's understand the problem. So in the problem we will be given three arrays: source array, target array and a swap array, and we have to calculate a value called Hamming distance. So one by one let's understand each term. What is the Hamming distance? Suppose if this is, let's suppose the initial case only, if 1 2 3 4 are the elements of source array and 2 1 4 5 are the elements of the target array. So what is the Hamming distance? What we do is that we calculate, means we compare the value at each index in source array and the target array. If the value differs, that both the value differs, then we add +1 to our Hamming distance. Otherwise we simply add 0 to our Hamming distance. So what we are seeing, both the, let's suppose there are few more elements, 6 6 and 7 7 is also present. Okay, so initially what we are seeing, 1 and 2 are different, so we'll add +1 to our Hamming distance. 2 and 1 are different, +1. 3 and 4 are different, +1. 4 and 5 are different, +1. 6 and 6 are same, so nothing will be added. For 7 7 also they are same, so 0 will be added or nothing will be added. So Hamming distance is 4. So this is what we have to do for Hamming distance. We compare each values at source and target, and if they are same then nothing will be added, otherwise +1 will be added to Hamming distance, and we have to calculate the minimum Hamming distance. What we can okay, we have to calculate minimum Hamming distance. And how will we minimize Hamming distance? That is by using this swap array. And what is this array? Swap array is, it indicates, means it denotes some indexes. Okay, so 0 and 1, it denotes 0 and 1. It means that in the source array I can swap 0 index at 0, element at 0 index, and element at 1 index. I can swap these two elements. Similarly there is 2 and 3 present, so I can swap the elements at index 2 and 3. Okay, but it is not like that we can use it only once, or we can use it in this pattern only. It is that we can use this as many times as I want. Like if I want 0 and 1, I can use it as many times as I want. Let's suppose there is one more, 2 3, 0 3 is also there. So what I can do, I can use like something like this: 0 1, then 0 3, then 2 3, then again 0 3, again 0 1. I can use this as many times as I want. Order does not matter, and number of times I am using them also does not matter. So I can use them any number of times in any order. What I have to do is that I have to use this swap array and rearrange the elements in the source array such that the Hamming distance minimizes. Okay, so that is what our task is. So I guess the problem statement would have been clear. Now let's analyze it for this example test case. Let's suppose 1 2 3 4 is given to us. So what we can do is that, what we are seeing in the target array, we want 2 1, something like this. And what we are seeing, we have a swap of 0 and 1. So if we swap 0th and 1 index, what we will get? We will get 2 1, 3 and 4 full. Now what we are seeing, that we want 3 and 4 is present in source, and we want 4 over here. So if we use this swap 2 and 3, we will be able to get this 4 at index 3. So if I use this swap 2 and 3, then we will get something like this: 2 1 4 and 3. Okay, we can use more, means if we want we can try more swaps, but we are not going to get anything better than this configuration. Okay, so eventually what we will get is 2 1 4 3 and 2 1 4 and 5. Okay, now if we calculate the Hamming distance, what we will get? 2 and 2 are same, nothing will be added. 1 and 1 same, nothing will be added. 4 and 4 are same, nothing will be added. 3 and 5 are not same, so +1 will be added. Okay, so Hamming distance for this particular config, means source, target and swap, will be what? 1. So this is what the solution will be for this particular problem. So I guess now the problem would have been clear. Now let's move on to the approach, like how are we going to actually solve this problem. Okay, how can we solve this? So for that, I have like a bigger test case. I have so that I could explain more better. Let's suppose, if we one by one, let's look at the things one by one. Okay, so we have a bigger swap array this time. Like, but swap array, there is something we can get from this swap array. What? Let's suppose we have an array. If we have a small array, let's suppose I'm taking another array for example. For now, zero, no, let the elements of this array be 1 2 3 4 and 5. Let these be the elements, and swap array here, let be what? 0 and 1 be one swap array, 1 and 2 be, and 2 and 3 be a swap array. Okay, so if we look at these swap arrays individually, what we can see is that, what we see that we can swap 0 and 1 element. So what I can think is that at most what I can get from this is, what I can get is something like this: 2 1 3 4 5. This is the at most I can get from this swap, nothing else. If I reswap this, then again I will get the same configuration. If I look at this swap 1 and 2, then at most what I can get from this swap, I can get something like this: 1 3 2 4 5. If I reswap it again, I will get this particular configuration. And if I look at this swap 2 and 3, then I will get something like this: 1 2 4 3 and 5. If I reswap it again, I will get back to the original result. Okay, so if we look at these swaps individually, then we are not going to get enough like configurations. But what I have told you earlier, like what I have told you, that we can use this swap any number of times. Like 0 1 can be used any number of times, and order also does not matter. Like I can use 0 1, then 1 2, then again 0 1 I can use. If I use this particular configuration, then I will be able to generate more patterns, like more particular combinations of these numbers I will be able to generate. Okay, so let's look at it something like this. Let's suppose eventually I was at max, what I was able to do: 0 1 1 2 and 2 3, 1 2 and 2 3. What I was able to do, I was able to swap only adjacent elements. Like for 2 1 I was able to swap, or I was able to swap 2 3, or I was able to swap 3 4 adjacent. Nothing else I was able to do. Okay, but what I am saying is that if I use first, if I use 0 and 1 swap, if I use 0 and 1 swap first, what I got something like this: 2 1 3 4 5. Now I am using 1 and 2 swap. So what I will get if I use 1 and 2 swap, I will get 2 3 1 4 5, 2 3 1 4 5. Now if I look at the result, what I have done, I have done a 0 and 2 swap. So what are we seeing from here, that there is one element common in 0 1 and 2, and we are able to group these elements. Since one element is common between 0 and 2, I can make some combination of 0 1 and 1 2 swap, and I will be able to perform a 0 and 2 0 and 2 swap. Okay, so this is what I wanted to focus upon. Like you can group this swap. If there is some common element between two swap, then we can group this swap, and there exists a combination by performing which we will be able to perform swap any element from any index to any other index in that particular group. Like we saw over here, 0 and 1 is one group, 1 and 2 is another group. One element is common between 0 and 1, so we can group this element into a single group: 0 1 and 2. And just now I saw that first I performed a 0 1 swap followed by a 1 2 swap, and I am able to get a 0 2 swap. Okay, so we can group these swap indices if they have something in common. Let's take one more example. If suppose we have a swap something like this, we have a 0 1 swap, 1 2 swap, and 2 3 swap. So I can, since there is something common between 0 1, 0 and 1, and 1 and 2, one element is common, so I can group it: 0 1 and 2. Okay, now if I look 0 1 2 and 2, there is something common between 0 1 2 and 2 3, so I can group it: 0 1 2 and 3. Now since these are in a claim in a single group, so what I'm saying is that I can swap any indices between this group. Like I can make a 0 3 swap, I can make a 0 2 swap, although it was not even present originally. Like there is no 0 2 0 3 swap originally present, but there is, we can make some combination of 0 1 1 2, and we will be able to generate a 0 3 swap. Let's take an example. Let's suppose there is an array of 1 2 3 4 5. There is no such combination of or let's suppose there is no combination of 1 and 3 swap over here. Okay, like 0 1 1 2 and 2 3 is present, but since they are in a same group, so I'm saying that we will be able to perform a 1 3 swap by some combination of these swaps. Okay, let's see if we are able to perform it or not. Okay, so 0 1 2 3 and 4, these are the indices. So I want to perform a 1 3 swap, 1 3 swap. Or how will I do that? Means I want 2 to go over here. What I can do is, first I will perform a if I perform a 1 3 swap, what should be my result? My result should be something like this: 1 4 3 2 5. This should be my result. Okay, let's see if I am able to achieve it using some combination of these swaps or not. What I will do, I will first perform a 1 2 swap. Then what I will get something like this: 1 3 2 4 5. Then I will perform a 2 3 swap. 2 3 swap. If I perform a 2 3 swap, then what I will get: 1 3 4 2 5. Okay, now if I perform a 1 0 1 and 2 swap, again let's perform a 1 2 swap, then what I will get: 1 4 3 2 5, and I am getting the final result, right? So by some combinations of this swap I am able to get it. So we can group this, means if there is some common elements, we can group these swaps into a single group, and we will be able to swap elements in a single group by some combinations. We will be able to swap any two indexes. Okay, so this point is useful to us. So we will be grouping these indices like swap array, we will be grouping it. Okay, so now let's see how will we be grouping it. We will be using disjoint set union data structure for this. Okay, we will be using disjoint set union data structure for grouping it. What we will do is that, let's make an array. So for this problem, what we will be doing, let's make an array. So at most we have what, 0 1 2 3 4 elements. At most we are going to have 4 elements, means 4 indices. So 1 2 3 4 and 5. Okay, initially 0 1 2 3 and 4. Initially what we do, will it is a parent array. So what we will do in design set union, every element will be parent eventually. Okay, now one by one what we will see, which elements can we group. Okay, so we are seeing that 0 and 4 are in a single, 0 and 4 can group, like 0 and 4 are swappable, so we will group 0 and 4. Okay, so 0 and 4, let make 0 as parent, so 0 will be parent. For 4 also 0 will be parent. Now 4 and 2 are in a group, it is given, but 0 is already the parent of 4, so what will happen, 2 will also start pointing to 0, and parent of 2 will be also be what, 0. Okay, now let's move on to the next element. 1 and 3 are in a group. Okay, okay. 3 points to 1, no problem. Now 1 and 4 are in a group, but 4 already points to 0. 0 is leader of 0 is leader of 4, so 1 will also what, point to 0. But here what we are saying, 3 is pointing to 1, 1 is pointing to 0, so 3 will also start pointing to what, 0. So for 3 and 1 also, parent will be what, 3 also parent will be 0. For 1 also parent will be 0. So in this case, all elements started pointing to one particular element only. That means what, 0 1 2 3 4, we can swap the elements at these indices. Means I can swap element at 0 to 1 2 3 and for any of the position. Same for 1, I can swap the element at index 1 to 0 2 3 for any of the positions. Okay, so this is what is, let's move on to the problem part. So now this much part is clear. Now how are we going to solve this problem? What we are saying is that these 4 elements, means these group of 5 elements can be swapped among itself. So these represent indices. Okay, so let's make actual values also. What are those values which can be swapped? So since 0, index at 0, index at 1, 4 and 2 3 can be swapped. Okay, so what are the elements at index 0 1 2 3 and 4? So index 5, index 1, index 2, index 4 and index 3, these 5 are the elements. So these 5 indexes in elements are there which can be swapped among these indices. Okay, so if I want a 5 to come at index 1, I will be able to perform that. If I want a value, if I want 3 to come at index 0, I will be able to perform it. That is what it meant. Okay, so this part is clear. So how will we move on? So what will we do? We have done this much part. After that we'll move on to the target array. This is our target array. Target array 1 5 2 4 and 3. This is index 0, index 1, index 2, index 3, index 4. Our source array is what, 5 1 2 4 and 3. This is our source array. Index 0, index 1, index 2, index 3, index 4. Okay, so in my target array, when I see target array says that I want index at index 0, I want 1. Target array says, so can we have an index, means can we have value 1 at index 0? So what we are saying, index 0 and index 1, all these are connected, like what, these are connected. So can we have an index 1? In this particular case, all the indexes are connected, so no problem at all. So means we can simply swap any values from any place to any place. So we want a 1. Do we have a 1? We are seeing that yes, we have a 1. So there is a 1 present at some other location, but it will get, means we can swap it by some combination of some swaps, but we will be able to bring it to place 1, and we have one particular value of such 1. So it is possible. So we said yes, we use that 1 and we will be able to provide 1 to you. So I said okay. So that means that in my target array I am able to swap, by some possible combination of swaps, I am able to bring the 1 at position 1. Okay, now let's move on to the next element. And from next element, target array says that I want a 5 at index 1. So again, since all the indexes are connected, so I will be able, if I have a value 5, then I will be able to bring it at this location by some possible combination of swaps, but only I have to check that whether I have a 5 or not. So I'm saying yes, I have a value of 5. That means I says okay, I will be able to bring it, man. So says okay, yes, I will be able to bring the 5. Then says okay, we move on. We are able to move on. We are able to bring a 5. Now this target array says I want a 2. So since all indexes are connected, I will be able to bring a 2. Only point is that whether I have a value of 2 or not. So I check in my unordered map or in my container that do I have a 2. Yes, I have a 2. So I said that let's use that to bring to this particular position. So I brought 2 to this particular position. Okay, now let's move on to 4. Again, I will be able to bring 4. Only the point is that do I have a 4 or not. I have a 4, so I use that 4. Okay, I brought it to this particular position. Same for 3. I have a 3. I used it. I brought it to this particular position. After that, after this particular operations, what I got, my source array got converted to what? 1 5 2 4 3. And my test target array is what? My target array is also 1 5 2 4 3. My target array is also 1 5 2 4 3. Now if I calculate a Hamming distance, what I am getting, these are same 0 0 0 0 0. So my Hamming distance is what? 0 in this particular case, since I was able to replicate the target array by using these particular swaps. Okay, so this is the algorithm which we are going to use. I know there are some more points which are need to be means explained more better. What we will do is that we will move on to the coding part for now. While coding, there are some points which are needs to be explained. So when those points come, we will come back to this particular part and we will explain. We will try to look upon them. What are those points? Okay. So for now, whatever we have understood, let's try to make these groups. Let's try to try and write some code, and then let's get back over here. Okay, so for now let's move on to the coding part. This is not required to us. Yeah, this figure will be required to us a little bit, like this array part and all this. So let's move on to the coding part for now. So now let's code this problem. So as discussed, we will try to means we will be making groups of these swaps, and for that we will be using this event set union. So let's start with that. So we'll make an integer array parent, but what will be the length? So integer n equal to source dot length length. Okay, so this swap contains what? Indices. So maximum index value will be what? The index of this particular source array. So our parent will be what? Of length n only, new integer of n, and initially every element is parent of itself. So plus I, parent of I equals to I. Let's make a array rank also. Integer array rank equals to new integer of size n, and arrays dot will rank with 1. Every element with rank 1. Okay. Now what we were doing, we were means moving in this swap array. We see that 0 and 4 are in a group, 4 and 2 are in a group. So we are using swap array to make the groups. Okay, we'll use that. So for integer array swap in allowed swaps. Okay, one by one. Integer a equal to swap of 0, integer b equals to swap of 1. Okay, now we will check, means find the parent. Find function we will use. So integer leader of x equals to find a comma parent. Integer leader of y equals to find b comma parent. If leader of x is not equals to leader of y, then what we will do? If rank of leader of x is greater than a rank of leader of y, and what we will do? Parent of leader of y equals to leader of x. Else if rank of leader of y is greater than rank of leader of x, then what we will do? Parent of leader of x equals to leader of y. Else we can make anyone as parent. So parent of leader of x equals to leader of y, and plus rank of leader of rank of leader of y. So we have made these groups. Like we are simply using the joint set union, means union over here. Let's write the find function also first, then we'll move on to the further part. So let's write a function find public integer find it will have two parameters, integer x and an integer array parent. We will check if x equals to parent of x, then what we will do, we will simply return x. Otherwise what we will do, return parent of x equals to what, find parent of x and parent. This is nothing but this is simply we are using DSU, so you can refer those videos if you are facing any confusion over here. Till now we have done nothing, we have only made the groups. So else part, if part, and we have only made the groups till now. This is simple DSU. We are just checking if 0 and 4 needs to be in the group. If they are not in the same group, then we are making into a we are making them into a same group. This is what we have done till now. After that, what we were doing, like, since there can be multiple groups, like there can be a group like 042, indexes of 042, there can be a group of 013, not 0413, 513, something like this, there can be group. So what we were showing, at each group we know that any element can be, means by some possible combinations we can swap elements between 0, 4 and 2. But what are those elements? So we were making a hash map data structure to store like what particular elements this group have. Like this element has, this group has 0, this group has 1, 3 and 5 as element. Then let's suppose this group has, if this group has 2, 2, 3, 3, 3 and 5 element, then how will we store it? Okay, so like I want some kind of frequency over here. So what we can use is that to store which elements are present in a particular group, we will use a hash map of integer comma integer. We can use a hash map of integer comma integer to store which group has how many elements. Like we can store that this particular group has 3 2s and 1 5 and 3 6. We can store something like this. So for that we will be using hash map. And one more thing, like there can be group something like this, 0 1 3 is the group. Each group has one leader, like 1, and 5 7 and 9 is a group. Let's suppose it also has a leader. Let's suppose 9 is the leader for this particular group. So what we are storing, how many, which, okay, so any elements can be swapped between these indices is okay, but what are those elements? So for that we are maintaining the hash map, like 5 is occurring 2 times and 7 is occurring 9 times, something like this. Okay, but how will we store it? So what we are going to store is that we are going to use hash, like all these 0 1 and 3 has collectively these many elements, not individually. So what we will do is that we can make a hash map of integer and hash map of integer comma integer. This is what we are going to make. Why this is hash map of integer comma integer is nothing but storing this particular part, like how many elements are present. And why this hash map of integer? Like each element has a leader and this group has collective this many elements. So what I will do, I will represent each group with its leader. So this integer is for representing the leader. Okay, and this particular leader has this many elements, and I know that in this group I can swap elements by some combinations, and these are the elements present with me. So we'll make it. So let's write it. So what we will do, hash map of integer comma hash map of integer comma integer comma integer. Let's name it map1 equals to new hash map Okay, now we need to fill the values. So what we will do, for integer I equals to 0, I is less than n, plus I, integer leader of x equals to find I comma parent. Okay, now what I will do, integer value equal to sourc source of I. Okay, if negation map1 dot contains key leader of x, then map1 dot put leader of x comma new hash map. Okay, then what we will do, if let's make another hash map of integer comma integer s equals to map1 dot get leader of x. If negation s dot contains key, contains key, this element. Negation is dot contains, negation is dot contains key, this element, that is value. If it does not contains, then what we will do, s dot put, put value. No, what we will require, like what we are doing at each h map, what is the value, so we will store 0 over here. S dot put value comma 0. Otherwise what we will put, no, not required. We can simply put s dot put value comma s dot get value plus 1. Okay, so we are done with this part. So what we have done till now is that one by one we are moving on this like parent array, and we are finding like 0. I'm asking to 0 which particular group do you belong to. Like let's suppose 0, 1 and 3 belong to a same group, and 1 is the leader, so it says 1. Okay, so what value does this particular index has? 5. So I will go, and in this particular, I will, in front of 5, I will increment it by 1. Now I'll move on to 1. I will ask which particular group do you belong to. Since 0, 0, 1 and 2 are belonging to the same group, 1 says I am also belonging to 1. So in front of 1, what is the value over here? 1. So in front of 1, I will increment by 1, and so on. So this is what we have done till now. So now now we'll calculate the Hamming distance. So Hamming distance equals to 0. So how are we going to calculate Hamming distance? Is that we have this particular array with a means with data structure with us, which element has how many values. So one by one we will, let's see, it this. So we'll 1, 5, 2, 4, 3 is our target array. So what I will do, I will one by one move into the element over index 0. I will go to, this is the index 0. So I will ask to index 0, means in this in your particular group, you can swap the values, but do you have a value which is equivalent to 1? If you have a value 1, then we can swap it. Then we will not increment the Hamming distance. And if you does not have value 1, then my Hamming distance value will increase, because you cannot supply the value 1. That is what we are going to do. We will move for integer I equals to 0, I is less than n plus plus I. Okay, what we'll do, one by one, integer, we will find first leader of x. Leader of x equals to what? Find I comma parent. Okay, and integer required value is what? Required value is target of I. This is the required value. Okay, now we'll get hash map of integer comma integer s equals to map1 dot get leader of x. Okay, and if this s does not contains this particular key, negation s dot contains key, this value, then what we will do, we'll simply increment the value of our Hamming distance. We will continue. Why? Let's suppose 1 is required, and in this particular hash map 1 is not present. That means what? 1 value cannot be supplied. So simply my Hamming distance value will increase. Otherwise what will happen? I will check if s dot get, what is the value? If s dot get value is less than equals to 0, less than or equals to 0, then also my Hamming distance value will increase. And s dot put, otherwise my Hamming distance value will not increase. And s dot put value comma s dot get value minus 1. Okay, and finally we have to return the Hamming distance value. So what we have done over here is that we are first checking that if the value is not present over there, then Hamming distance value will increase. Otherwise, if value is present, then what? I will check the count. If value is greater than 0, that means then my Hamming distance value will not increase. I will use it. But if value is less than equal to 0, that means that value is not present, so my Hamming distance will increase in that case also. Okay, so this was for the coding part. So I guess you guys would have understood it. So yeah, this was for the coding part. Currently the test cases are not updated in our portal, so I am not able to submit the question right now. but yeah, you can use this code, like the idea for solving this particular problem. By the time you will code this problem, test cases will be updated on our portal. Okay, so I guess the idea, problem and the solution would have been clear to you guys.